We ended the last video looking at a certain type of matter called pure substances, and those were elements and compounds. But today we're going to take a look at mixtures. And mixtures are another type of matter because it's made up of particles. But the property of a mixture that makes it different is that these can have varying or different compositions. They're not fixed. A fixed composition like water never changes. It's always H2O. But a mixture can have a variety of different compositions. For example, salsa and pizza. So take a look at this picture. I've seen salsa. Not all salsa looks the same. That bowl of salsa here doesn't look like all the types of salsa I've ever seen or that you probably have seen either. That's because one person's salsa isn't the next person's. And so there are different compositions, different ingredients are added or left out. And so that would be a mixture. Same with pizza. I've seen all types of pizza and the different toppings and so on. It's a mixture. It's not uniform. It's not the same from one person to the next. Mixtures are classified by how well the parts are evenly or not evenly distributed or mixed up. There are two main types of mixtures. The first one is a heterogeneous mixture, and so this would be a mixture where the particles are noticeably different. A lot of the times they're large enough that you can even see them without needing a microscope or anything. You probably have had school lunches that look like peas and carrots, and you can tell the peas from the carrots. It's a heterogeneous mixture. It's made up of two different items that have been mixed together in the same container, and you've put it on your plate. So that would be an example of heterogeneous. Homogeneous mixtures, the particles are usually a little smaller, and so the particles are more evenly distributed throughout the whole entire solution. And it's difficult to tell one particle from the other. It looks the same, so that would be homogeneous or homogeneous. You've probably seen swimming pool water. When I look at this, it looks like it's all the same. Very clean. From one end of the pool to the other end, it looks like it's the same material. But yet if you looked closer at it, you would see that there was chlorine in it. There's probably other chemicals mixed in there as well, but you don't see the chlorine. You don't see the water different from the chlorine, different from the other chemicals. It looks like it's one thing in that pool. So there are really three different types of these types of mixtures. Okay, we have solutions, suspensions, and colloids, and we base them based off their particle size. And we're going to go a little out of order, but we're gonna start with solutions first. And solutions are a homogeneous mixture, so these are going to be uniformly mixed up, evenly distributed. You're not really going to be able to see one particle from another. Tap water would be an example. Assuming that you don't live out in the country and have very hard water where the iron will sink to the bottom, that's something different. But let's just say tap water from in town. If you put that in a glass, you can't tell that there might be dissolved particles in there. Most cities treat their water so that they add chemicals to kill bacteria, and a lot of the times fluoride to help with teeth. So you can't see that, and it doesn't look like there's anything else in there. Every single mixture, you can look at three different characteristics to help you decide whether or not it's a solution, a suspension, or a colloid. And for a solution, you would, if you put it through filter paper, like a coffee filter, and you were to dump this Kool-Aid into the coffee filter, it would all pass through. Nothing would get trapped on the other side of the filter. So no substances are trapped. If you were to take a flashlight and put shine the flashlight in on one side, the particles are small enough that it allows the light to pass right through. So it shouldn't reflect the light or cause it to look foggy or anything. And then the third characteristic is that it doesn't settle over time. So you could leave that Kool-Aid sitting out for a few hours and it shouldn't separate into Kool-Aid and sugar and water. It should look like it still does there in the picture. A second one was suspensions, and suspensions are heterogeneous, meaning that you should be able to see the particles. They should look different from each other. And with heterogeneous mixtures, most of the time you can separate them into layers over time. Even 10-15 minutes, they'll start to settle because of how big the particles are. They're heavier. So this would be a suspension. You can tell that there's dirt settled to the bottom of this container, and it also has a very foggy look. So there's obviously other particles mixed in there. So if we go through our three characteristics, if we were to pass light through here, we wouldn't be able to see it straight through. It would get scattered. It looks very cloudy. If we were to take filter paper and dump that container into the coffee filter, it would catch the larger particles. And over time it does separate into layers, at least 2 layers, sand maybe on the bottom and then the water on top. The third type was colloid, and a colloid is kind of the intermediate size. So these are the middle-sized particles, and they're still considered a homogeneous mixture, but they are a little bit bigger than solutions, but not as big as suspension particles. Some examples, fog and smoke and milk. Fog being one that we're very familiar with here in Indiana and probably hope for many mornings. But if you take a look at fog, and let's go through the 3 tests here. No substances would be trapped if you tried to pass this through filter paper. The particles aren't big enough to get trapped. If you pass light through it, it obviously scatters light, becomes very tricky to be able to see through it. And over time it doesn't separate into layers. It stays kind of evenly mixed there. So that ends our video about mixtures. Again, there are 2 types, homogeneous and heterogeneous. And within the 2 types, then you have 3 possible examples, which are suspensions, colloids, and solutions.